Hi everybody, welcome back to another video lesson. The last little while we've been looking at chapter 4, and in chapter 4 we've looked at things like the distributive property and how that works. We've also looked at how we can start to use algebra. We looked at like terms and unlike terms, coefficients, variables, and the idea of how we can start to represent algebraic expressions. Just so you know, it's the morning of the ski trip. I've been here since about 10 to 6. It's currently about 7 o'clock as I'm getting our lesson ready. If I make a few mistakes, I apologize because I'm a little sleepy, but we'll fix this up. Extending algebraic skills, some of our key ideas, so we'll get our note down first. Monomials can be multiplied, or divided. There's a couple mistakes already. Divided, where the variables are the same or different. Remember, we looked at variables and how we can have a variable term. It's like 5x or negative 7y squared would be a variable term because there's a letter in there that can change. Now, today's concepts we're going to go through a bit more slowly than we have in the past, and I'm going to do a few more examples than I have in the past because it's a bit confusing. We're going to first of all do some of these for review. If we are distributing these, if we're multiplying these two terms, I've got 2x times 3y. I multiply my coefficients and I get 6, and I multiply my variables, but I can't multiply an x and a y and get a single answer, so it's actually xy. The one of the below here, so we're going to go to this one now, 2x cubed times 5x squared. We've also got to think back to chapter 3 and looked at our exponent laws. When we are multiplying powers with the same base, and the same base here is the x, we can't add our exponents. So we still need to multiply our coefficients. We've got 10. And now we want to multiply our variables, and we have x cubed and x squared. So what I want to do here is say, well, I can add those exponents. I can add my 3 and my 2, and I get x to the 5. So I have 10x to the 5 as my answer there. Well, now we're going to start to look at some division. And up here on this division question, I had to draw the line because it didn't show up on my sheet. I can also distribute this or divide these things, divide the denominator into my numerator in kind of the same way that I would on a regular question. So I want to say, okay, what is 6 divided by 2? We know that 6 divided by 2 is 3. But now here comes the tricky part, is how many times does x go into xy? Well, I'm going to go off to the side here. If we had xy, really what I want to do over x, really what I'm saying is this. X divided by x, I want to take that x and divide it into both, and I want to do this. Okay, so it looks a bit weird, but that's really what I'm doing is we're getting the same thing. So let me get rid of that. So what I'm doing here is the x will disappear because they're really going to cross out. And then we are left with a y. So my answer there is I have 3y. So 6xy divided by 2x equals 3y. In my next question down here, we're going to have a look at it. Let's see what we can do. We have to remember our exponent laws on this one. And our exponent laws, since when we are dividing with exponents and we have the same base, we can subtract the exponent. But first of all, let's do our coefficients. Our coefficients are 10 and 5. Well, 10 divided by 5 is 2. And then I can look at my base. I've got an x. That's my variable. And we have 5 minus 2. So we got an x. 5 minus 2 is 3. And there is the answer for that one. So I've got to go back to those 6 exponent laws that we looked at in chapter 3. Well, let's look at our next part here. These questions will make a little more sense, hopefully, as we get some more practice at them. So the distributive property is used to multiply or divide a polynomial by a monomial. Remember, a polynomial can have many terms. A monomial has just one term. When multiplying by a monomial, so by one term, each term of the polynomial must be multiplied by the monomial. And that's a distributive property that we looked at the other day. And we'll look at this again as we take an example here. So in this question right here, this constant, which is outside of our polynomial, it's the monomial, we want to multiply it by each of the things in the polynomial. So we want to distribute it to each term in the polynomial. So let's have a look here and see what we got. We've got 2x squared plus, 2x squared times 3x. So 2 times 3 is 6. X squared times x squared. For multiplying with the same base and the same variable, we can add our exponents. So we're going to do the 2 plus the 2, which is going to give us a 4. The next one, we have 2x squared times 5x. So we're going to have 10. We're going to add our exponents. So we're going to have x cubed. And lastly, we're going to say, okay, 2x squared times a negative 4. We're going to have a negative x, and we have an x squared. So there is the answer for that one. Our next part says when dividing a monomial, by a monomial, each term of the polynomial must be divided by the monomial. Now I'm going to expand this question here so that we can see it. So this is the one we're going to look at. So we've got 6x cubed plus 2x squared minus 8x, all divided by 2x. So really what I can do here is I can say, well, it's really 6x squared cubed divided by 2x plus 10x squared divided by 2x minus 8x divided by 2x. So first of all, I've expanded the question so I can see it. I don't have to always do this step. I just wanted to show you that we can break it up. And now I'm going to look at each one. So I'm going to look at this piece first, the 6x cubed divided by 2x. And we're going to say, okay, 6 divided by 2 is 3. X cubed divided by x, if we think back to our exponent rules and our exponent laws from chapter 3, we know that we can subtract our exponents. So 3 minus, there's no exponent here, so we have to assume that that's a 1. And we know that that's a 1, so we've got 3x squared, not cubed. 3x squared. The next one is 10x squared divided by 2x, which is going to be 5, because 10 divided by 2 is 5, and x squared divided by x, it's going to be a single x. And lastly, we have 8x divided by 2x, which is just going to be a 4, because the x's will cancel. I mean, we're not really canceling, but they have an exponent of 1, and 1 minus 1 is 0. And our sixth exponent law that we looked at said that anything to the exponent 0 is 1, anything times 1 is itself, we leave it as 4. Remember, throughout these videos, you can pause at any time and kind of go, what's he talking about? Maybe review some of the stuff and go back and you rewind or pause and just kind of think about some stuff going on. Let's look at some of these examples. We've got a bunch of examples that we can do, and I think we'll go through most of them as this part is a little more complex. So this is a multiplication question, and for number 1, we want to distribute that constant into the polynomial. So we're going to say, well, it's equal to 4x times 2x, and 4x times 2x is 8x squared, and 4x times a negative 4 is going to be a negative 16x. And there's the answer for that one. On the next one, we want to take that 2x and we want to distribute it and multiply it by each of the terms in the polynomial. So let's go ahead and start that. And we've got 2x times 3x, which is 6x squared, plus 2x times 4x, which is 8x squared. Then we have a 2x times 1, which is going to stay at 2x. Now some of you might say, hey, I'm done this question, but really we can simplify this because we have like terms. We have two terms that have the same variable, and those variables have the same exponent. So we're going to simplify this even more and say, well, if I have 6x squared plus 8x squared, I've got 14x squareds plus 2x left over. And then there's that one. Next question, looking at number 3, similar kind of question. We're going to throw in a negative in there just to have some practice with some negative numbers too. We've got 3x times 5x squared. Well, 3 times 5 is 15. X times x squared, thinking back to our exponent law, we can add our exponents. So we've got 15x cubed. 3x times a negative 4x, I'm going to have 12x squared. And then this last one, I have 3x times 1. Anything times 1 is itself. And there's our last question. As I keep moving on to number 4, I've got two variables in there, so this question now. So a little bit trickier again. So 2x times 3x and 2x times 2y. Looks a little trickier. It's actually not if we kind of think it through. We're going to have 2x times 3x. 2 times 3 is 6. X times x is x squared. In this one, we've got 2 times 2, which is 4. We can't multiply our x and our y, but we can just write xy. And that one's done. We can leave it at that. In question 5, we've got a negative coefficient, which we haven't had before, so we've got some negative multiplication on each one. Negative 4y times 2x, we can multiply our coefficients, and we get negative 8, and we have an xy. Now you might have noticed on this question and the one before that I've listed the variables alphabetically. So we want to list our variables alphabetically. We don't want to do a y before an x, do an x before a y. Next part I have is negative 4y times a negative 4y. Well, a negative times a negative is going to be a positive. 4 times 4 is 16. Y times y is going to be y squared. And then we do the next one. We have negative 4y times 2xy. This is a little bit weird because this term here, has two variables in it. But we know how to do things with two variables. We'll just say, okay, we know it's going to be a negative. 4 times 2 is 8. We've got 1x. We can multiply our y's together, and we actually get y squared. And we can leave it like that. Now, some people may say we should probably reorder this, because normally you put the highest exponents at the front. And I could say this is going to be negative 8x y squared plus 16y squared minus 8x xy. That's the other one way we want to represent it. Usually the highest exponents go first. So we've got the next one. We're done our multiplication. Now we're going on to some division questions. And division questions, again, are a little trickier. I'm going to expand these and go real slow on these and break it up. So I'm going to say it's going to be 4x squared divided by 2x. And then we have plus 10x squared divided by 2x. And we have a plus 2x divided by a 2x. And these are a little bit more manageable when we break it up that way. Now some of you can just go, you know what, I'm going to take that 4 or 2 divided into the 4, that 2 divided into the 10, that 2 divided into the 2, and then I'll worry about my variables afterwards. But I like to do it this way just to slow it down, and I can see each piece then. Well, 4 divided by 2 is 2, and we can think back to our exponent laws when we're dividing powers that have the same base or the same variable. we can subtract our exponents. We're going to be left here with a 2x. And here we're going to have a 10x squared divided by 2x. We know it's going to be 5. We're going to have 1x left. And 2x divided by 2x, so something divided by itself, is always going to give me 1. Now before you say, hey, I'm done this question, we have to look here and say that we do indeed have like terms. So let's finish this question off and let's combine our like terms. So it's going to equal 7x plus 1. So there's that question finished. So lots of stuff happening in that question. A great example of combining like terms and also doing some division with monomials and distributing a monomial into a polynomial. The next one here, we have 4mn squared plus 4n squared minus 8n divided by 2n. Well, let's break it down a little bit. We're going to say 4mn squared divided by 2n plus 4n squared divided by 2n minus 8n divided by 2n. And we're going to break this down a little bit here. And what do we get? We're going to have 2m n. Now we can't, in this one, it's a bit weird because I don't have an m down here. So the m's going to stay. I can't divide it, so it's got to stay. Let me get rid of that little red dot yet. Here we go. We have 4n squared divided by 2n. And so we're going to be left with 2. And we know that our division rule for exponents, we subtract them. So we're going to be left with 1n, or just an n to the 1. And this one, 8n divided by 2n, we're going to be left with 4 because the n's will, well, the 1 minus 1 is 0. Let's look at this next one here. The 15mn divided by 3m is actually a little bit easier than it looks. We know that 15 divided by 3 is 5. The m's, if we were to divide an m by an m, we're going to be left with 1. So we're really just left with the 5n on that one. Last one here, again, looks tricky, but it's really just a good application of our exponent law as we're dividing. So we have, first of all, our coefficients. 28 divided by 4 is 7. Use your calculator for that if you need to. X to the 5th divided by x to the 3rd. Our exponent law says we subtract our exponents. So we have x squared, y cubed minus y squared. Our exponent law, we subtract our exponents. 3 minus 2 is just 1. And lastly, z to the 7 divided by z to the 5. Our exponent law, again, we subtract our exponents and we get z squared. And that's our answer. There's a bunch of examples here as we look at the distributive property. We'll be working on some more examples in class, and you can look down at the bottom of the sheet or the bottom of the screen, and you can see the examples I'd like you to try when you finish up this note. So lots of stuff happening here on this video. I'd love for you to check it out. Try these ones. Work with a partner if you have to understand things. Don't be afraid to ask some questions. I'll be coming around and helping you out also. See you in class.